Hello everyone, welcome to Chemspires. In this video we'll look into the question question number 1.12. If the density of methanol is 0.793 kilograms per liter, what is the volume needed for making 2.5 liters of its 0.25 molar solution? So let's see how we shall solve it. So for better understanding, let's write the given data separately. So density, which is denoted by rho, is given. So density of methanol is given as 0.793 kilogram per liter, and volume is given as 2.5 liters, and then molarity is given as 0.25 molar. A solution is nothing but a combination of solute and solvent. Here the solute is methanol and solvent is water. It is not mentioned as water, but generally the solvent will be water. So methanol is solute, so we are writing it as density of solute. So let's write the molarity formula. So molarity is nothing but number of moles of solute, here it is methanol, divided by the volume of the solution in liters. We know the volume of solution, but we don't know the number of moles of solute. So let's think how we can calculate the number of moles of solute. Number of moles can be calculated by the formula mass by molar mass. So even here we don't know the mass, so we can calculate the mass using the formula density is equal to mass by volume. Because density has been given in the question, we can get this clue of using this formula to find out the mass. So mass can be rewritten as density into volume. So using this, let's find out the mass, and we can put the density into volume in place of mass, so that number of moles will be equal to density into volume by, that is, volume of solute divided by molar mass. So here you should not write as volume of solution, because number of moles is actually we are calculating for solute, so you should be careful in writing that volume of solute. Okay, and now we have the expression for number of solute, that is number of moles of solute. So let's substitute this in the molarity equation in the place of number of moles of solute. So molarity equation will become density into volume of solute divided by molar mass and into volume of solution in liters. Now we have the full form of the equation. So let's substitute our known values in this equation, so we can get the final answer of the concentration. So molarity is given in the question as 0.25 molar, which is equal to rho, that is density, which is 0.793 kilogram per liter. And since volume of solute is unknown, let's write as X, and divided by molar mass of solute, which is molar mass of methanol. So we can calculate it. Methanol is CH3OH, so for carbon it is 12, for hydrogen it is 3, plus oxygen 16 plus 1 for hydrogen. So it turns out to be 32 grams per mole. So let's substitute into volume of solution in liters, which is given in the question as 2.5 liters. So let's take X to the one side and all other known terms to the other side. So we'll get 0.25 molar can be written as mole into liter inverse into 32 into 2.5 liters. Actually this is 32 grams per mole. Okay, so let's write it. So it will be 32 grams per mole into 2.5 liters divided by 0.793 kilogram liter inverse. So here let's strike out all the units which can be cancelled out. So we'll get 0.25 into 32 into 2.5 into 10 power minus 3 liters. 10 power minus 3 we are writing because we are converting grams to kilograms, which is nothing but 0.0252 liters. 1 liter is nothing but 10 power 3 milliliters. So we can write 0.0252 into 10 power 3 milliliters. So since it is 10 power 3, we should take the decimal 3 times to the right side, so it will be 25.2 milliliters. So we can write the final answer as volume of the solute is equal to 25.2 milliliters. That is 25.2 milliliters of methanol is required